Hello everyone. In this video, let's discuss about 8:1 multiplexers or MUX. If you are new to our channel, please subscribe for more engineering related topics. So while discussing about 8:1 multiplexer, we can easily identify that there will be 8 number of inputs and only one output will be there. So to select the input which must go through the single output, we will be using the selective lines. So first let us write their block diagram. First let's write their block diagram. Next, using this block diagram, we will be writing the truth table. Next, using the truth table, we will be writing their equations, that is the characteristic equation or the logic equation. Fourth step will be, using this equation, we will be constructing a circuit or logic diagram. Circuit or logic diagram. So, at first let's start with the block diagram. What is block diagram? Block diagram is the simple representation of what are the inputs and what are all the outputs of the given circuit. So in 8:1, I already said that there will be 8 number of inputs and only 1 number of output. So we can easily represent them in a block diagram. So this is 8:1 multiplexer or MUX, you can write. 8 inputs, 1, 2, 3, 4, 5, 6, 7, 8 number of inputs and single output. Let me call this output as Y and inputs as I0, I1, I2, I3, I4, I5, I6 and I7. So total I0 to I7 means total 8 number of inputs and single output Y. So using this block diagram, we will be constructing their truth table. In the truth table, we will be representing their both inputs and outputs, that is inputs and outputs. Since we have more number of inputs, there will be. So at input and output side, if we see, output is Y. So we know the value of the output, but which input will be selected will be depending on the number of selective lines. So inputs will be the selective lines. Selective lines will be acting as the inputs in the 8:1 multiplexer. So how many number of selective lines are required? So total how many number of inputs are there in 8:1 MUX? 8. So how can we represent it using the 2 powers? That is 2 power 3. 2 2s are 4, 4 2s are 8. 2 power 3 will be equal to 8. So 3 number of selective lines are required. If it was 4:1 MUX means 4 means how can we represent 4? 4 can be represented using 2 power 2. Therefore 2 numbers of selective lines would have been required. But here 2 power 3, that is 8 inputs. So 3 number of selective lines are required. So let me call them as S0, S1 and S2. So you can name them any name, but I call them as selective line 0, selective line 1 and selective line 2. Now these selective lines will be acting as an input in the 8:1 MUX. So let's write them. S2, S1 and S0. Since we have 3 inputs, what are all their combinations? So the combinations will be 4 0, 4 1, 2 0 2 1, 2 0 2 1, 0 1 0 1 0 1 0 1. Now let's assume that if S2 value is 0, S1 value is 0 and S0 value is 0, it will give the input I0 as an output. So let me call it as I0. Like that only I1, I2, I3, I4, I5, I6 and I7. So now we completed the construction of the truth table. Using this truth table, we will be constructing the equation. For whom we will construct the equation? We will construct the equation for the output. So what is the output? Output is Y. So Y is equal to, we will be using the inputs and the outputs also, that is S2, S2, S1, S0. What is their output? I0. What are the values of S2, S1 and S0? 0. So you will use bar. S2 bar, S1 bar, S0 bar, I0. Next, first one is done. Second one, S2 bar, S1 bar, S0. Why I wrote S0? Its value is 1. So I1 plus S2 bar, S1, S0 bar, I2 plus S2 bar, S1, S0, I3 plus 2, S1, S0, I7. So now we completed the formation of the characteristic equation using the truth table. In the next step, we will be drawing the circuit or the logic diagram for these equations. So now to draw the circuit diagram, what are all the inputs we are using? S2, S1 and S0. Their bars also. Bars means 0. So we will be using NOT gate in front of them, and I0, I1, I2, they are all there. So how can we construct? So the circuit diagram. First one is S2, next S1 and S0. This will act as the major inputs. So we are having S2 and S2 bar. S2 bar means NOT gate. Now, what are all my inputs? Inputs are I0, I1, I2, I3, I4, I5, I6, I7. So these 8 are my inputs. So using this one, I must construct. So first, what is the equation? First one. So the first one is S2 bar, S1 bar, S0 bar, I0. Bar means in NOT gate you must use. So S2 bar, S1 bar, S0 bar and I0. So this I will be adding through AND gate. Why I am using AND gate? Between them dot is there. That is multiplication. So that like only you construct for all. What is for the second one? That is I1, S2 bar, S1 bar and S0. S0 means use this one, not the NOT gate one, and I1. So use the AND gate. Like this only complete for 7 also. Like this only complete for all of the 8 in. Now we constructed for all of them using the AND gate. So what is in between all of them? Plus is there. What plus represent? Plus represent OR gate. So we must connect all of them to a single OR gate as the output. So we will be connecting all of them to a single OR gate. So this is the output Y. So here the end of the 8:1 multiplexer. Hope you understood the concept. If you have any doubt, please comment below and subscribe for more engineering related topics. Thank you.